Letter M, discuss relative dating and the law of superposition. So Hutton is the scientist that came up with relative dating. Write that down. Okay, Hutton came up with relative dating. Relative dating tells us the sequence in which events occurred and not how long ago they actually occurred. Okay? So it's like a relative date. Like I know I'm 42. You guys are what? 15, 16, 17, 18, maybe somebody's 14. I got some freshmen, I don't know. Um let's say I have a rock, okay? And it has a dinosaur bone in it, okay? What can you tell me about the age of that rock? Okay, it's got to be old because it has a dinosaur in it, dinosaur bone, sorry. But can you pinpoint an age? Well, if you know that the dinosaurs became extinct 65 million years ago, we can say that that rock is at least how old? 65 million years old. Okay, why is it 65 million years old at least? Because we know that the dinosaurs got wiped out 65 million years ago. Could it be older than 65 million years? Absolutely. But it's at least 65 million years. And that's what relative dating is. It doesn't necessarily tell you an exact time, but it can tell you something's older or younger than something else. All right, so here's some laws you should know. This is where geologic puzzles are going to come into play. We're going to do a lot more of geologic puzzles next class, or whatever day, Friday, Monday, whatever day you have me. Don't want to give you too much today. So Steno, not Mr. Stento, but Steno is another scientist who came up with the law of superposition. The law of superposition states that in an undeformed sequence of sedimentary rocks, each bed is older than the one above it and younger than the one below it. So these rocks, these colors represent a layer, just like the Grand Canyon. And this had to be deposited first before this, before this, before this. So this is the oldest rock, and it gets younger as we move up. Letter N. Discuss the principles of original horizontality and cross-cutting relationships. Original horizontality says that the layers of sedimentary rocks are generally deposited on a horizontal fashion, or in, I guess would make more sense, a horizontal fashion. So let's go back, okay? That's how rocks should be deposited, right? And here's these rocks. I got a question. Is this an anticline or a syncline? Ooh, do you remember? It's shaped like an A, so this is an anticline. So as these rocks get pushed and shoved around by planet Earth or by our tectonic plates, moving and grooving, okay, and as they become folded and faulted, the oldest is still at the bottom, okay, and the youngest is at the top. So this one still would have been deposited before all of these. Sorry, that's my dog, Sophie. All right, cross-cutting relationships. Cross-cutting relationships is when a fault cuts through or when magma intrudes or cuts through other rock. It is younger. Okay, Sophie. Sorry, guys. She has to be by me and then she heard a noise. So, cross-cutting relationships. So let's look at this. All right, so we got the oldest is 1, then we have 2, then we have 3. Oh, but this isn't number 4. This is younger than this. Okay, now why? Well, I use it, my example is the Twinkie and the filling. Okay, what had to come first? The Twinkie or the filling? Okay, the Twinkie. You can't have filling and somehow bake a Twinkie around the filling. So if you think of 1, 2, and 3 being the Twinkie, number 4 would be the filling. So it had to come last. So the oldest rock is 1, then 2 is younger, then 3 is younger. Number 4 crosses it, so it is next. 5 is the youngest. Some of you, now this is what geologic puzzles are, by the way. Some of you might be wondering, well, why isn't 5? Why isn't it red, green? Is this blue or purple, yellow, then orange? Does anyone know why number 4 or this orange is younger than number 5? It's because it doesn't cut into number 5. Number 5 isn't the Twinkie, okay? The filling doesn't cut into it. Now, that puts it being younger. This is this relative dating. Looking over here, this would be the oldest. So it'd go 1, 2, 3, 4. Now this would be number 5 because it cuts across all of the other layers. That's the difference between these two pictures. Here's a fault, okay? So this is an intrusion. We learned this before, I don't remember what chapter, but is it a dike or a sill? It's a dike because sills are horizontal and dikes are vertical. It's not big enough to be a batholith or a laccolith. So when you're doing these geologic puzzles, I want you to kind of reverse everything if you can mentally. If you can't, that's okay. So that means this would have been up here, this would have been up here, this would have matched that. So C is somewhere down here, right? Because is it a normal fault or a reverse fault? That's the question. This is your foot wall, right? This is your hang wall. Looks like your foot wall went up, your hang wall went down. That is a normal fault. Well, the fault cuts across all of these layers. Okay, it cuts across the layers, it cuts across the intrusion, cuts across the dike. So it is younger than everything. Okay, so what's the oldest? So we know E is the youngest because it cuts across or cross cuts. We have to go from the bottom, being the oldest, all the way to the top. So we're gonna ignore D real quick. So your oldest would be C, and then going from oldest to youngest, B, and then A. But what about D? D cuts across C, B, and A. So it's the filling. So that means it's younger. So the order of oldest to youngest would be C being the oldest, then B, then A, then D, and then E. E is the youngest because it cuts across not only the layers of sedimentary rock, but it also cuts across this intrusion. Here's another one. What I would like for you to do is I would like for you in your notebook, on a piece of paper, however you, I'd rather you write it down. I know some of you aren't going to do this because I'm not there watching you. But in class, I would have you write this down. Write the letters down. What I want you to do is I want you to pause the video right now. Well, in a minute. And I want you to write the oldest to the youngest. Okay? There's a fault right here. You don't have to tell me about the fault. But letter H is an intrusion. So pause it right now, and I want you to go from oldest to youngest on your piece of paper. Okay, so now I have to think because I can't pause. I mean, it could pause it, but hopefully you guys paused it and you have your letters written down. Let's see what we got. So I know that this intrusion cuts across everything, even R. See how it goes into R? It doesn't go vertically in, it goes horizontally. So this is kind of turning into, this is a dike. This is a sill, maybe turning into a laccolith. So what is the youngest? Let's do it kind of like a mental reversal, right? B would move up, F would move up, M would move up. So the oldest is I. Then we have B. And then we have F. And then we have the fault, but you guys might not have labeled the fault. That's okay, I didn't ask you to. Then we have M. Then we have R. And then we have H being the youngest. So I, B, F, M, R, H. You might have put the fault in your answers. The fault is younger than I, B, F, and I'm on the fence about M, maybe M too, because it's kind of going into M. There's erosion there. It's hard to tell. All right, so think about this one. I want you to, again, in a moment, pause the video, and I want you to write from youngest to oldest what's happening, okay? All right, hopefully you paused it and you wrote down your answers for practice. So we got a crosscut, right? So A cross cuts into B, C, and it actually cross cuts into D. Not that much, but that tells us sorry guys, it's my dog, that tells us that A or D had to be there before A. So the oldest is B, because it's at the bottom, law of superposition. Then we have C. Then we have D. Then we're going to say A. I know there's no way to tell if A is younger or older than E, but because it crosscuts, we have to make an assumption. So B, C, D, A, and then E would be the youngest. Here's another one. I want you to do the same thing in your notes or on a piece of paper. Okay, I want you to go oldest to youngest. I want you to pause the video and write it on your paper. Okay, so Z and X, this is a dike and this is a batholith or a laccolith. Both of these are igneous intrusions. That means D is the Twinkie and these two are the filling, okay? Z cuts across X and D, so Z has to be younger than both. They had to be there first. X cuts across D only. So the oldest is D, then X, because it crosscuts D, and then Z is the youngest because it crosscuts X and D. All right, I know you're probably getting sick of these. Let's try one more and see if you guys can do this one, okay? Again, if you'll pause the video and practice on your paper, and I'll give you the answers. Okay, hopefully you paused and did so. Before we go for this one, I want to draw your attention to letter B. B is an intrusion, okay? Igneous intrusion, probably a batholith. And then F is also an igneous intrusion. And you can see F cross-cuts B in all of these, and B cuts across these. So just looking, you could hopefully tell that H is going to be our youngest, and D is our oldest. Even though these rocks have been tilted, right? Original horizontality, the law, these rocks would have been deposited horizontally. So our oldest is D, then J, then I, then A, then G. B, because B cuts across all of those, but it doesn't cut across F. Then E, then C, because F cuts across all those. After C, we'll say F, and then H is the youngest.